यहाँ से यहाँ से स्टार्ट करते हैं 1 सेकेंड रिमाइंडर में। चलो ये दिस वाज द लास्ट क्वेश्चन, क्वेश्चन नंबर 4। ठीक है, वी गोना स्टार्ट विद क्वेश्चन नंबर 4। तो क्वेश्चन नंबर 4 इज अबाउट बेंजीन। ठीक है, कि एक्सप्लेन द स्ट्रक्चर ऑफ बेंजीन। तो also can explain how the orbital overlap leads to the formation of sigma and pi bonds. ठीक है, it's a 3 mark question. अच्छा, it's a 3 mark question. तो पहले मैं क्विकली ना आई एम गोना एक्सप्लेन कि व्हाट इज कौन सी हाइब्रिडाइजेशन होती है बेंजीन में। डज इवन नो व्हाट्स द हाइब्रिडाइजेशन?
sp2.
ठीक है, इट इज sp2। तो उसके अंदर कार्बन इज मेकिंग 3 bonds। Three of its electrons are making 3 bonds। ठीक है, एंड द 3 bonds are कि there is a bond with H, ये भी H, just 1 second। अच्छा, then there's another H, फिर एक और H, and then there's another H, and then there's one sp2 में it makes 3 bonds, and then you have one p orbital। So there's a p orbital which there's one electron left। So there's a p orbital left, and that p orbital is used for making pi bonds। ठीक है, and the pi bonds overlapping is going to be sideways। ठीक है, so these two would overlap, uh, but since there are 6 of them that are parallel to each other, they all start overlapping with each other। ठीक है, so they all start overlapping, and you get a ring of benzene of pi electron clouds above and below। अच्छा, now the question, we're going to come back to the question। पहले तो state the hybridization। ठीक है, we're just going to answer, we are just going to answer 1 second what। अच्छा, so we are only going to answer what he's asking for। ठीक है, remember question में deviate नहीं होना, just stick to what they're asking। State the hybridization of the carbon atom, so that is sp2, that's 1 mark। ठीक है, and explain how the orbital overlap leads to the formation of sigma and pi bonds। So one by one, the carbon bond, can anyone tell me which orbitals actually overlap to form the carbon carbon sigma bond over here? ये जो middle वाला है, ठीक है, I'm going to highlight that। ठीक है, it's this one, and let me get rid of the pi bond। अच्छा, which orbitals form the carbon carbon sigma bond? ठीक है, remember it's sp2 hybridization। तो यहाँ पे just hold on a second। अच्छा, so carbon carbon sigma bond, remember carbon is sp2 hybridized। So if I highlight this carbon atom over here, all these orbitals are actually sp2 hybrid orbitals, and this particular carbon carbon sigma bond over here, ठीक है, this one, that's actually 2 carbon atoms, and both of them are sp2 hybridized। ठीक है, so ये वाला भी, this one over here, that is also making 3 sp2 hybrid orbitals। So the carbon carbon sigma bond is formed when you have an sp2 overlapping sideways end-to-end overlap। ठीक है, sigma is when they form an end-to-end overlap। ठीक है, is this clear? And then you have the carbon and 8 sigma bond। ठीक है, there's another sigma bond that's forming। Single bonds are all sigma bonds। So that's a carbon and 8 sigma bond, so you have to explain how that happens। So carbon and H sigma bond is that carbon has an sp2 hybrid orbital, 3 of them, right? H ke paas, what does H have? H has an s orbital. So this overlapping that's happening over here, okay, the H only has an s orbital, while the carbon has 3 sp2 hybrid orbitals. So the carbon and H sigma bond is getting formed when you have the sp2 coming from a carbon and an s orbital that's coming from an H, and they start to overlap end to end. Right? Is this clear? You clear, Saroko? Or
Yes, sir.
finally, and finally you have to explain the pi bond. Okay, how does that explain how the orbital overlap leads to the formation of a pi bond? So the pi bond is getting formed over here, which is the p orbital of a carbon atom overlapping with the p orbital of another carbon atom, right? So यहाँ पे I'm going to just write the only thing that's needed now is how is the pi bond getting formed? So it's a p orbital overlapping sideways. ठीक है, just explain this a little bit. Okay, it's an sp2 orbital, sp2 orbital overlap. ठीक है, I forgot the word orbital over here. So just add the word orbital over here. sp2s orbital overlap and a p and p sideways orbital overlap. ठीक है, just add the word orbital to all of this. Is this clear?
Yes, sir.
Yes, sir.
Acha, up next one. So you've got a benzene and it's being there's a whole reaction scheme that's given. So you have to go from this benzene all the way to this thing over here, and there's an amine that's getting attached to it. So each side pin, I'm just going to try and open the. Just 1 second. Let me open the organic reaction chart. ठीक है, ताकि वो clear हो जाए. Just a second. If I have this over here, otherwise I'm just going to explain it otherwise. ठीक है, A2 spider chart here. Yep. Acha, so I've got a benzene. ठीक है. So my starting point is this thing. It's a benzene. So I have to attach an amine to it. ठीक है, benzene. So I have to make it into a nitrobenzene, and then I have to reduce it to turn it into an amine. So it's basically this part over here. But then वो जो product था ना, that it also has a carbon chain that's attached to it. So how do I attach a carbon chain to it? That's alkylation. That you start off with a benzene, and you have to attach an alkyl chain to it. So it's this part over here. You do alkylation, you react it with a halogenoalkane with an AlCl3 catalyst. Okay? So there are two things that are required. Now, the only trouble is, अच्छा वो मेरा खत्म हो गया. एक second. Let me just open the paper again. Just 1 second. So the only trouble is, I have to be careful about 2,4,6 and 3,5. If I take a benzene and I nitrate, so I've got two options. Either I do alkylation first or I do nitration first. Now, let's say I do alkylation first and I attach a carbon chain to it. The carbon chain has an electron donating effect. It's a 2,4,6 directing group, which means that any other group that's going to be attached, it's either going to be attached at position number 2 or 4, which is fine. Because the NH2, the next thing that's going to be attached is that it's going to be attached at position number 4. So electron donating groups are all 2,4,6 directing groups. How do I do alkylation? I need this molecule, which is CH3, CH2, so CH, and it's got to have a Cl attached to it. So this carbon is positive, which is why this carbon gets attached to a benzene. There has to be an AlCl3 catalyst and plus heat. So next step is that I'm going to nitrate it. How do I nitrate it? I need concentrated nitric acid. I need concentrated sulfuric acid. And the temperature has to be around. So the next step is I'm going to copy this and I'm going to attach an NO2 at position number 4. And after that, what needs to be done is I need to reduce it. How do I reduce NO2? It's 10 plus concentrated HCl. Okay, that's it. That's your reducing agent. So that's it. Okay, that would pretty much answer all the rest of it. So the opposite would have happened. You can remember the only thing you have to be careful is okay, if I had nitrated it first, the NO2 is an electron withdrawing group, and an electron withdrawing groups are 3,5 directing. So what that would do is that, and I do alkylation later. So the alkyl group would then get attached to position number 3. So the order was very important. That the alkylation has to be done first, and then the nitration has to be done. Okay, is this clear?
Yes, sir.
Yes, sir.
Okay, okay, so one more time, I'm just going to explain the TK. Remember this chart. TK, you have a benzene, you nitrate it, and then you reduce it. TK, ये heat मैंने miss कर दिया. TK, make sure you add heat to it. And alkylation, how do you alkylation? How to do alkylation? It's an alkyl chain. It's a halogenoalkane. TK, you got a Cl, the carbon जो होता है, that's positive, and that positive carbon atom is going to get attached to the benzene if there's catalyst present. So going back to the question. TK, the rest was on. So give the systematic name of this thing. So this is a methyl group, this is a methyl group, and this one is also a methyl group. Now the first thing is that if you have an amine, so what do you call this thing? Amine hota, so that's what is it called? It's called a phenylamine. And it's got methyls, right? So
Yeah,
there's
1, 2, 3 trimethyl phenylamine.
again 1, 2, 3. This is 1. So this
Oh, okay.
is
Oh,
3,
okay.
4.
4,
So you got 3, 4, 5. Trimethyl phenylamine. Okay. Now it shows the number of peaks observed in carbon-13 NMR spectrum of W and Z, right? So complete the table. So I'm going to go with W first. So how many different carbon-13 environments are there? Starting with, इसको पहले rub कर दें. Starting with, let's get rid of this. So how many different carbon-13? So this is a unique carbon with a totally different environment compared to the rest. So that's the first peak that you're going to get. These two carbons over here are exactly identical. They are bonded in exactly the same way. So they're going to resonate together. So they will have one peak. Okay, next one. These two carbons are also they're exactly the same. So they're going to resonate together. That's the third peak. Uske baad kya? You got I think these two carbons are exactly bonded in exactly the same way. So this one is going to be my fourth peak. So this one is going to be my fourth peak. Then you have this carbon atom, which is completely different from all the rest. So that's your fifth peak. And this CH3 carbon that's different from all the rest. So that's your sixth peak. Yeah, okay. So you've got W is going to have 6 carbon-13 environments, and there will be 6 different peaks. सही है, clear है? And Z भी था, there's Z as well. Where is Z? Z is this one. So how many different environments would this have? This is one. These two are exactly the same, so they're going to resonate together. So that's the second peak. These two are also exactly the same, so that's going to be your third peak. This is different, so that's your fourth peak. This is different, that's your fifth peak, and these two are exactly the same, so that's going to be your sixth peak. They will resonate together. So again, so remember, if they're bonded in exactly the same way, they will resonate together, and they will have one peak.
Sir, can you go
ये
up
part
for a second? For W.
W.
W. Yeah. Okay.
So next one. Exhaust system of modern gasoline fuel, so it's catalytic converter, right? You can remember the three types of metals that are used as catalytic. He's asking for that. Name three metal catalysts which are used. There's platinum. There is palladium. And then there is rhodium. ठीक है? और ये वाला, I'm just going to confirm this one more time.
Sir, what about iron?
Iron is definitely, I'm pretty sure iron is not used as a catalyst in the catalytic converter.
Okay.
ठीक है, लेकिन इसका मैं कंफर्म कर रहा था, since S23 MS41 just double checking it. Just 1 second. As I explain what is meant by the term heterogeneous catalyst, right? एक second, S2341 ठीक है, खुल गया. Just give me 1 second. ये वाला part ना, let me just double check this one. ये है, ठीक है. Explain what is meant by the term heterogeneous catalyst. That's what is it? It's a catalyst that has a different phase. ठीक है, it's got a different phase compared to the reactants. So the next part is that there's an exhaust system of many. So there's liquid urea that decomposes on heating. So this happens, and then there's another reaction that's happening that water vapor then reacts with HNCO to form ammonia and carbon dioxide. So some values for standard enthalpy change of formation. Achha, when you're given enthalpy change of formation, the formula for finding enthalpy of reaction is that it's the enthalpy change of formation of the products minus the enthalpy of formation of the reactants. Okay? So what is meant by the term entropy of a system? That's simply, it's a measure of disorder of a, I mean, there are many definitions. This one over here is the simplest, okay, which is going to be accepted. So it's the measure of a disorder of a system. That's it. It's another I mean, there are other definitions which are more complicated, but this one is sufficient. Use data to calculate delta G, right? Which is Gibbs free energy. How do you calculate delta G? Delta G is delta H minus T times delta S, right? So you need delta H first. The temperature is known, and you also need delta S as well. So you have to go back and you have to calculate both of them. Or which reaction are we talking about? Use data for reaction number 2, right? So we have to calculate both delta H and delta S for reaction number 2. So reaction number 2, right? The first thing is I'm going to calculate the delta H. So enthalpy of formation is given. So the enthalpy of this reaction is going to be product, which is CO2, that's minus 393.5. then you have this one. That's a minus 393.5, and then you have NH3, which is minus 45.9. So that's product minus your reactants, which are HNCO, that's minus 102 minus 101.7. So it's going to turn into plus. And H2O, that's minus 241.8. Achha, can anyone try and do this? Okay, what's the answer for this?
Minus 95.9.
Minus 95.5, right?
0.9.
So minus 95.9. Now, the other thing is I have to calculate delta S as well. Delta S pretty much also has the same formula, which is the entropy of the products minus the entropy of the reactants. Okay, so if I do that, that's CO2, that's 213.8 plus the other product, which is NH3, that's 192.8 minus your reactants, which is HNCO, that's 238.2, and then minus the other reactant, which is H2O, that's 188.8. So what do we get for delta S?
Negative 20.4.
Yeah, that's negative 20.4, right? So you've got both values now. And you can now calculate delta. I'm going to do it over here. You can now calculate delta G, which is delta H, which is minus 95.9. So that's delta H minus T, which was 25 degrees centigrade. I think it was 25. But it has to be in Kelvin. So that's 298 Kelvins. So minus T times delta. Let me write this over just to avoid confusion. So T times delta S, which is also negative 20.4. Now, one of these values is in joules and the other value is in kilojoules. Your delta G is always in kilojoules. So you have to convert everything in kilojoules. So this 20.4, which is entropy, that's in joules. It has to be divided by 1000 as well. The minus signs will actually become plus. So what do we get?
Minus 89.8.
Yes, it's minus 89.8 kilojoules per mole. TK, you have to be very careful with this thing because always remember that one value is in joules, the other one is in kilojoules. So if you put them in the formula, either turn both all of them into joules or turn all of them into kilojoules. So next one, you've got ammonia formed in reaction. You've got ammonia. Use the equation for reactions 1, 2, and 3 to construct an overall equation for the reduction of NO2 by. So there's a reaction 3 happening as well. So the overall process is that you had a reaction number 1, then you had a reaction number 2, and then you had a reaction number 3 as well, which is over here. So use the equations for the reactions 1 to construct an overall equation for the reduction of NO2 by NH2CO. So you basically have to combine all the 3 reactions. And I don't know why that's for 1 mark because it's going to be very time consuming. Hopefully everything in between will get cancelled out. So you have to add the 3 reactions. Here you've got NH3, right? In reaction number 2, you have NH3 getting produced, right? And the first reaction, there's still NH3 getting produced as well. So in total, what's happening is you've got 8 NH3 that are reacting in the third reaction. So in the first two reactions, you should have 8 NH3s getting produced, right? So I think we're going to start with 4. Okay, remember the third reaction that I have, that has 8 NH3s getting produced, getting the 8 NH3s that are reacting in that reaction. So the first reaction produces 4. The reason I did not go for 8 is because this HNCO that was produced in the first reaction, 4 of them are going to react with 4 H2Os, and it's going to produce 4 more NH3s, right? So the first reaction produces 4 NH3s. Then in the second reaction, this HNCO goes and it ends up, because it's already balanced, the 4 HNCO that are produced in the previous reaction are going to produce 4 more NH3s, right? So the first two reactions have in total produced 8 ammonia molecules. And then finally, those 8 ammonia molecules go and react with NO2. And they eventually turn into N2 and 12H2O. So now what I need to do is, remember the whole steps, I need to balance the 3 equations simultaneously now. Is this thing clear? Okay, why I did 4 over there and 4 in the second one? Is this thing clear?
Yes, sir.
Yes.
Yes, sir.
So now the thing is, I need to cancel things that appear on both sides. Because it's overall, I'm going to cancel all intermediates. 4 HNCO were getting produced. 4 HNCO got used up. So that's gone. So then you have 4 water molecules, CO2s, and 8 NH3s were getting produced. And in the third reaction, 8 NH3s got consumed, right? So that's gone. So what am I left with? I'm going to write, I think nothing else is getting cancelled out. There are 6 NO2s, but I'm just going to total all of them up now. So there's 7 N2 in the products, there's 12 H2Os in the product as well over here. I'm just going to focus on the products at the moment. So what's left in the other products? That's the only thing that's left is 4 CO2s. So there's going to be 4 CO2s as well in the product. Then I'm going to focus on the reactants, right? So there's 6 NO2s that are in my reactants. So who's in my reactants in the other 2 equations after cancelling all of them? It's 4 H2Os and 4 of those things as well. So यहाँ पे you've got 4 H2Os and 4 NH2 twice CO. This H2O is also going to get cancelled out like a math equation. You get this 4. You can get rid of this, take it to the other side. So it will get subtracted and you'll be left with 8.
If you
Right?
don't cancel the H2O, will it still be fine? Or no?
I mean, the equation will still be fine, but I think the equation will still be fine. It will still be fine. I'm pretty sure it's going to be accepted.
Yeah.
Okay. But as I like, the whole trick in this question was to get the balancing right, and the balancing would only be right that you had to somehow. Because इस reaction में there were 8 NH3s that were reacting, right? So the trick was that you had to produce 8 NH3s in the first 2 reactions. ठीक है, आपने is this clear?
Yes.
Because otherwise the balancing. But the trouble is that this is disappointing that they just gave us 1 mark for this. Plus, there's no shortcut to this. You have to do all of this. So the next thing is isocyanic acid HNCO can form cyanuric acid under certain conditions. It has a cyclic structure containing alternating carbon atoms and nitrogen atoms in the Higgs system. So suggest a structure for cyanuric acid. How would you do that? So isocyanic acid can form, first thing, it's got a cyclic structure, alternating carbon and nitrogen atoms, right? So that's one. So there are 3 carbons and 3 nitrogens.
Can't you just add like, no, never. Yeah, you can add like 1 hydrogen and nitrogen on each carbon. Okay.
1 hydrogen and 1?
It was like make like a tricycle, like with just 1, 2, 3 carbons, and then add like a nitrogen on each, and then no, you can't do that.
I'm done with
Okay.
they were alternating carbon and nitrogen atoms. So I'm done with the carbon and nitrogen atoms. I'm left with 3 hydrogens and 3 oxygens. So the 3 hydrogens is easy. Let's say this is 3 hydrogens, right? So the carbon bonds are still not complete. The carbon is supposed to have 4 bonds. And the nitrogen is supposed to have 3 bonds. So what if I
Could it be that the oxygen binds to the carbon and nitrogen?
it could be like this. The nitrogen needs 1 bond, so I can add an H over here. The oxygen needs a double bond, right? So carbon gets 4 bonds, nitrogen gets 3 bonds. This is how it's probably going to be. This way, everyone gets the right number of bonds. Is this clear?
Yes, sir.
As a next one, it's about weak acid pK. What's pK? pK is the negative log. P is the negative log of. P stands for negative log. What is pH? P stands for negative log of the concentration of H positive ions. pK concentration, always put a square bracket around it. Now calculate the pH of HNCO. Now remember that HNCO, when it dissociates, it produces H plus 1 and NCO minus 1, right? So your K expression or your equilibrium expression for this is, equilibrium constant expression for this is, so remember this is basically H plus 1. Okay? So it's H plus 1 concentration into NCO minus 1 concentration divided by HNCO concentration. Or to simplify this, both of these ions will have the same concentration because they'll be producing an equal amount. So the easier expression is this one, that it's H plus 1 squared divided by the acid concentration. Anyway, so you have this thing, and the K value is also given. The K value is not given, the pK value is given. So you can calculate if you want to, you can calculate the K value, which is inverse K, or what's the inverse of pK? That's 10 to the power minus 3.7, and it's H plus 1 squared. And I know the acid concentration, which is 0.12. So quickly tell me what H plus 1 is then.
Sir, is 4.89 multiplied by 10 to the power minus 3.
Under root. Did you take the under root?
Yes, sir.
So how do you calculate pH? That's going to be the negative log.
Sir, it's 2.31.
ठीक है कितना 2.
31.
So this one is 2.31. So remember, if it's only the weak acid, this is the formula that you're going to use. Remember, there are 2 formulas. One is for buffer and the other one is for just the weak acid. The next thing is he's asking for the percentage of HNCO that is ionized, right? So HNCO concentration was, that was 0.12 mole per dm cube. When it got ionized, how much H plus 1 did it produce? Well, we just calculated it. It was, what was before taking the pH? What was the value? What was the H plus 1 concentration? 0.12. Is my calculator. Maheen, do you have a calculator?
Yes, sir.
was 0.05.
0.05?
0.005.
Yes,
You
sir,
have to
same.
need 3 significant pairs. Can't be 0.05. But it can be 0.05, but that's a rounded value. Tell me the more accurate value.
0.00489.
Okay, so 0.00489, right? So what is the percentage that got ionized, right? So out of 0.12, 0.00489 got ionized. So what's the percentage? That's 0.00489 divided by 0.12 times 100. Okay, so you had this much concentration and this tiny amount got ionized. What is the percentage that we're getting?
4.078.
Because it's 4.07. There's 0.83 significant figures. I said next one, question number 6. Name, so this one is easy one. Functional groups alkene, amine, and you have a carboxylic acid. Okay, so there are 3 functional groups. He then says that it exhibits stereoisomers. Draw the 3-dimensional structure for the 2 stereoisomers of H. So what type of stereoisomers would this have?
This one?
These cistrons नहीं हो सकता because the carbon is bonded to 2 H's, right?
It's optical. It's optical isomerism.
Yeah.
It's
So
at
this
the amine. Yeah.
yeah. So you're going to focus on this carbon atom, right? And draw the 3-dimensional structure. So you have to draw the 3-dimensional structure. ठीक है?
Sir,
That middle carbon atom.
is it fine if you place the H and amine and anything at the random points, or is the H always supposed to be at the top and like
नहीं,
the
it's complete. It's completely random.
Oh, because usually
Okay.
in MS they always keep the H at the top.
It doesn't matter because you can see it from any side, right?
Okay, and there's gonna be like 2 lines and solid lines and 1 broken and 1 triangle.
Yeah. ठीक है? अच्छा, हाँ, the one more important thing about optical isomers, right? And that is कि remember you can. I said now remember how do you draw the other version? And this might come in A2 as well.
And it's
I mean, this
2
usually.
carbon on the left side, and then you draw it like that.
हाँ, लेकिन the trouble is
It will be
the way.
dotted only.
हाँ, नहीं, the trouble is that this thing happens. The mirrored version only happens if the way that we are drawing it right now. It only happens if you think of the mirror being placed right in the middle. ठीक है, Amna, is this thing clear?
Yeah.
अच्छा, so it's going to.
But then in this question, it's only in the middle, right? Like we're not placing it anywhere else.
Yeah, in this question, it's up to you. I mean, you can place it in the middle. You can place it at. इसको किधर होना चाहिए था? It's probably going to be CH3 double bond.
तो आप CH आप क्या alkyl group ऊपर भी रख सकते हैं, like meaning कि वो भी accept होएगा.
हाँ, I'm telling you this ना कि what can happen is the mirror. अच्छा, you can place the mirror over here as well, right? So now the molecule is going to be mirrored upside down. This one was left to right. This one is going to be. The H will go to the bottom right. And the dotted NH2 will be over here, and this CH3 thing will be over here. And your COH will be over here. Right? Is this clear that you can have the mirror placed over here as well? I mean,
Would
over
they
here.
accept this though?
I mean, they will accept this.
Oh.
But then there's another problematic place where you can place the mirror. And that is because sometimes they give you that one, which kind of makes things very, very confusing. I said these two are pretty straightforward, pretty simple. The way you place the mirror. Now, the problematic place where you have to like really think in a three-dimensional way is, what if the mirror is placed right in front of you, like between you and the screen? How would the molecule look? Either left, right, okay, this is bottom. What about it's on the z-axis, right?
Isn't it the like जैसे जो lines हैं वो change हो जाएंगी like triangle and it will go somewhere else.
No, it's think of the mirror, like you see yourself in the mirror, right? So how do you? I mean, so this is the way I'm talking about. Okay, like there's a mirror in front of you, and you're looking at yourself. So you don't get flipped left to right. I mean, you do get flipped left to right in that case as well. You do actually get flipped left to right. But when it's right in front of you, when the mirror is right in front of you, right? What happens is that, like, if you point your hand towards the mirror hand is going to point towards you. Do you understand the point?
Sir, can you
I mean,
explain
let me
again?
It's
explain.
gonna be the same though. It's gonna be the same, right?
नहीं it's you गौर से सुनो जरा. What I'm trying to say is that imagine you are standing right in front of a mirror and you're pointing your arm towards the mirror, right? What is the mirror doing? It's going to point the arms in the opposite direction towards you, right? So if you're going into the page, the mirror is going to go out of the page. Do you understand this? Okay, imagine you're standing in imagine
Yes.
you're standing in front of the mirror and your hand is pointing towards the mirror, right? So the mirrored version is going to point the hand in the opposite direction towards you, right? So if you're pointing the hand into the page, it's going to point the hand out of the page. Is that clear?
Yes, sir.
Achha, so in that situation, this thing is going out of the page, right? So imagine if you're standing in front of the mirror. So this particular bond over here will be going into the page. And this one is going into the page. So in the mirrored version, it's going to be going out of the page. So the third problematic way of actually drawing a mirrored version is, okay, everything looks exactly the same. It's as if you're standing in front of the mirror, except that the bond that was coming out of the page is now actually going into the page. And the bond that was actually going into the page is now going out of the page.
Okay,
But
so
sir,
can you
That
explain what the triangle symbolizes, into or out of?
the triangle normally symbolizes out of the page.
Okay.
Like
and
this,
sir,
I mean,
sorry.
a second. This bond is actually coming towards you, right? So if if you're standing in front of the mirror, right? So this bond will be going into the page, right? And this thing was going into the page. So in the mirrored version, that will be going out of the page, right? As the reason I'm just telling you this is because they do give you examples like this as well in A2, right? Well, the other two are pretty straightforward. Okay, this one is slightly confusing. I mean, real question. There are like 2-3 questions where they actually what they did. Well, I'm going to tell you what they did was that they drew molecules like this, and they told you to put the groups on it. Okay, and so people got confused. Like, how do you put the group over here? Because it doesn't look like a mirrored version like they used to. Okay, is this clear? But
Yes,
is
sir.
this thing clear? So next one, compound H. I said, but don't worry about this. Normal mirrored version, 80% of the questions are going to be like that. This one, just slightly more confusing. And a compound H can be prepared from the reaction of J with an excess of hot aqueous acid. So J, where is J? Compound J. It's an. I said, what is compound J? It's an ester and it's an amide at the same time. Complete to show the equation for this reaction. So compound, yeah, so it's getting hydrolyzed basically.
The ester is breaking.
Yeah, the ester and the amide, I think both of them are breaking. Okay, the ring structure is opening up. So basically the ester breaks, or यहाँ पे ना the amide also breaks, right? So if the amide also breaks, this will become an alcohol. This is going to become a carboxylic acid. This one is going to become a carboxylic acid, and that one is going to become an amine, right? So I think the one that they drew was this one, which is this. The one with the amine and the carboxylic acid. The one that we have to draw is the other one. So that's two carbon atoms. One of them has an OH, and the other carbon atom has a carboxylic acid. Okay, is this clear? Or water is the one that's getting added to it? Name the type of reaction. That's obviously hydrolysis. As polymers consist of monomers joined together by undergoing addition or condensation. Polymers each can react to form an addition polymer or a condensation polymer. Draw one repeat unit of addition polymer K. So I'm just going to, now the addition polymer revolves around the alkene, right? So he's asking for, what is he asking for? One repeat unit of the addition polymer, right? That's going to be formed. So when it's an alkene that's forming the addition polymer, so it looks, you got two carbon atoms, double bond. The first carbon atom has two H's. The second carbon atom has an H, and it has this entire thing that's attached to it. Okay, there's a carbon, this one, and then that carbon has a carboxylic acid, and it also has NH2. How would it form the addition polymer? That the double bond would break and it will start forming linkages with similar molecules. Or that's, you can write in, that's your addition polymer. And after that, he's going to say, okay, we draw two repeat units of a condensation polymer. So the same molecule over here, this one, I have to draw a condensation polymer. So I'm going to draw this thing.
Isn't it the COH and amine reaction?
So there was a carbon and then there was a double bond carbon, right? This one has two H's, this one has one H's, and then there was NH2 over here. So now he's asking for two repeat units, so I have to draw another one. And or ab ye ki the OH and H condensation would happen. So the water molecule is going to be formed. And the two monomers, the monomer residues will join up. Or ye continue kara, this is also continuing on the left side. And they will form a peptide or an amide linkage over here. Okay, is this clear?
Yes, sir.
So last, what explain why condensation polymers can
They
bond
can
with
get hydrolyzed. Water can add it and bake it. They can get hydrolyzed.
No, but why? That's the question. Why does
Oh.
that happen?
Hmm.
Why not?
Because they are polar.
Okay, because they're polar. Okay. These are highly polar molecules. These bonds are highly polar and they're very water attracting, right? Okay, this is negative, this is positive. So the amide link is polar and water attracting. So hence it reacts with, or it's very reactive. Okay. Is this clear?
Yes, sir.
Sir.
चलो ठीक है अच्छा, my Google Classroom, and there's I guess how many questions left in this one? There's just one question left. I'm gonna give you an assignment on this one. Just this one question. Tomorrow we're gonna start with a new paper. Okay, there's just one question left, so that will be given as an assignment. Try and do that. Okay, I'm gonna make a Google Classroom and add this to it. It's just the last question that's left in this. Question number 7. So let's continue tomorrow then. Okay.
Okay, sir, inshallah.
Okay.
Thank you, sir.
Love this.